All right, hello everyone. My name is Aaron Standard, and today we're going to be doing something a little fun with Akka.net. We're going to go ahead and take Akka.net and specifically Akka.Streams, and we're going to gather CPU utilization data from an arbitrary number of processes that we're going to launch using a little bit of source code that we wrote. And we're going to gather all that data and render it into a live data table that updates on the console. So it's basically going to be like a little Procmon type tool that's all built using Spectre.Console. So this is all C# code. For how sophisticated this application is, there actually isn't very much code involved at all. And that's largely because of the excellent work of the Spectre.Console project and because of the bunch of the infrastructure that Akka.Streams provides us with. So without any further ado, let's jump into the code and see how this all works. So I'll go ahead and include a link to this repository in the description of this video, but all of our source code here for this sample is all open source. I'm planning on including some other Akka.Streams recipes here in this repo eventually. But for now, this is going to be in this little StreamRefs folder right here. StreamRefs are a technology we can use to have Akka.Stream span across multiple nodes in the network. So this is actually also going to use some of Akka.net's distributed systems functionality, specifically Akka.Remote, which we're going to use. We're not going to use clustering for any of this yet. If you want to learn a little bit more about Akka.Streams, you can go ahead and click this video up here. This will take you through sort of our introduction to it. But let's go ahead and actually get started by running a quick demo. First thing I'm going to do is I'm going to launch our metrics collector. This is our server, and this is where Spectre.Console actually runs. So I'm going to go ahead and fire this up. So you can see here that we have a little table, nothing in it right now. There's a address, a last update, and then there's going to be a CPU utilization number expressed as millicores. That's kind of like the Kubernetes standard for how we measure CPU utilization. So the next thing I'm going to do as part of our little demo here is I've got a number of different little consoles that are going to run the agent process. So I'll go ahead and do .NET run, C release, get that up and running. Do that. And we should see, yep, you'll go ahead and see that data gets populated there. Great, perfect. I'll go ahead and launch another one, and another one, and another one. 4 of them total. So we'll go ahead and let this ride. All right, there we go. Now, I'm not actually sure my millicore computation is correct. I got that formula off of ChatGPT, so you never know. So I might need to go ahead and revise that. That's a real simple one-liner inside our agent class. But you can see here we're getting all this data from all 4 of these different nodes. You can see basically how long it's been since the last update, and you can see what the millicore values are. So if I go and kill off one of these processes, let me go ahead and maybe terminate this one. All right, so that process is shut down. We're going to stop receiving data from it. You'll notice that this last update value is just going to keep climbing and climbing and climbing for that process. Once that value hits the 60-second mark, that record will go ahead and get deleted. We assume inside the way I wrote this application that if we haven't gotten any data within 60 seconds, that node probably no longer exists. Therefore, we're going to go ahead and remove it from the live view here. But otherwise, this is how we are basically building our application. It's a real simple table UI. And we could potentially add other metrics like memory and disk utilization on here too if we wanted to. We just went ahead and started with CPU utilization for now. So the next thing we'll go ahead and take a look at is how this application is actually built and how we are actually using Spectre.Console and Akka.Streams. All right, so we're actually going to start our demo by taking a look at the Spectre.Console bits down here. This is our Spectre.Console actor, and it's responsible for basically running the live update loop that we're going to use to render that table we saw on screen. Now, all the live update components in Spectre.Console aren't inherently thread safe, but that's not a problem for Akka.net actors. All actors process messages sequentially, one message at a time, so everything we do inside an actor is inherently thread safe. So in this case, when we start up the Spectre.Console actor, we're getting a reference to another actor, the metric aggregator, which is going to be running inside this metrics collector process right here. We'll take a look at that actor in a second. That's where all the real data comes from inside this little server process we're running here. So we wait until we get a... So one of the things that happens inside this actor is in our pre-start method, if I scroll down here, we tell the metric aggregator actor that we want to get a copy of the metrics feed. So we do that as soon as we start up. And we use behavior switching inside this actor right here. There we go. Where we start off in this waiting for metrics state. And once we get this reply back for the metrics feed, we're going to go ahead and save a copy of this channel reader inside this little mutable field right here. Channel reader is part of system.threading.channels. This is going to be where we get all of the metric updates for each of these nodes from. So we're going to go ahead and consume that inside our Spectre.Console update loop for this application. So we're going to switch our behavior back to the running state, and we're going to tell ourselves to begin to basically run.instance. We're going to start running. So down here, I'm going to go ahead and create a table. So this is a Spectre.Console table. I'm going to center it, change the color. I'm going to add a few columns to it. I'm going to add some instructions on how to quit the app. And then this is where we're going to add the live table right here. I'm going to go ahead and set some rules around cropping and overflow. But the start async method is where everything really happens. This is going to run outside of the actor's context, potentially, this little task we're kicking off here. But that's okay. The only piece of actor state we're going to end up passing into it is this channel reader right here. And this channel reader is an inherently thread-safe object anyway. And this channel reader is going to be getting some updates from all the other different agent processes that are connecting to us via Akka.Remote and Akka.Streams. So I have a little dictionary that we're going to create inside this asynchronous method. That's going to have the address of each node and its last metric update. We're going to go ahead and add an empty row to the table just to space it out when we first start. And whenever we call context.refresh with Spectre.Console, that's going to redraw the entire table. So we're going to go ahead and basically redraw the whole table. And what we're going to do here is we're going to call read all async on this channel reader. That is going to cause us to basically get an async enumerable. And for each event in that channel, we're going to go ahead and basically run this little routine right here. We're going to process the event, which will cause us to update this dictionary with all the appropriate, last updated values and the last metric result. And then we'll call process table right here, where I'm going to go ahead and clear all the rows from the table. I'm going to remove any items from this metrics dictionary right here where the data hasn't been updated in the last 60 seconds. That way we kind of assume that that node probably isn't active anymore. Therefore, we don't need to display it. So we'll just get rid of it. And then for each of the nodes that are still active, we're going to go ahead and add a row to them. And we're just going to do some pretty printing on the address, on the timestamp, and also on the data itself. So that's all that we're doing here. We're just going to go ahead and redraw the table each time we get an event. Another thing that we'll do is that in the event that we can't get any additional data, let's say there are no more events coming in, maybe because all of the nodes that were connected to us disconnected, we're going to go ahead and spin a little bit here using this loop. And this is just designed to help age out all of the, let's say, nodes that aren't updating anymore in the event that no one's connected to us. And eventually we'll go back to having an empty table again. That's all that this little method is for. In the event that there's more events waiting for us in the channel reader, we're going to go ahead and loop back up to the top again. So this is the Spectre.Console portion. And Spectre.Console is getting its data from this metric aggregator actor right here. The Spectre.Console actor sends us this request metrics feed message, and we send it back this channel reader that we've created in response. So that's basically how we kind of connect the dots there. Well, the way this actor works is it's using Akka.Streams. We create a channel sync right here. This is an Akka.Streams, what's called a sync stage. This is a destination we send events to. And this sync stage can be materialized into a channel reader. And this channel reader is a way we can sort of consume this data without having to be part of Akka.net. And you can see us already doing that inside the Spectre.Console code. So materialization refers to both like the compiler we use to go ahead and turn Akka.Streams into like an executable set of actors. But it also is about getting non-actor handles for interacting with the stream. In this case, all of the data that this stream is producing is all going to be written to this bounded channel. And that's all going to be something that we iterate through as an async enumerable later. And then we're going to put on top of this channel reader, we're going to go ahead and put what's called a MergeHub. A MergeHub is in Akka.Streams, a dynamic sort of source where you can basically attach multiple producers to it at runtime, and it'll start pumping all of its data into the sync that's running underneath it right here. And this sync, again, is the channel reader we had before. So when we first launch our server application, there's no one producing any data because no one's connected to the MergeHub yet. That'll happen a little later up here when we receive this push metrics message from one of the agents. This message itself contains what's called a source ref. This is a remote Akka.Streams data source. This data source is actually running in a separate process. That source ref, when we access it, we can go ahead and tell it to run with the sync that points to that MergeHub. And we can do that for an arbitrarily large number of source refs. So we can have thousands of source refs all writing to the sync if we want to. And that'll result in 1,000 rows on that Spectre.Console data table. For our little demo, we're just going to do 1 to 4 different sources there. And so we have this little messaging protocol I've set up for the agents that are running in a separate process where they ping us. We reply back with a request to subscribe. They reply back with a push metrics message that has the source in it. We reply back with an acknowledgement. So a little bit, 2 round trips of communication. The way this whole program runs, this is just using Akka hosting, which you can learn about here. This is kind of like our way of integrating with the Microsoft.extensions ecosystem. We basically just disable logging because we don't want any background console logging to interfere with Spectre.Console. We open up Akka.Remote on port 9912 on localhost. This is where we're going to accept incoming connection requests. Then there's some extension methods I wrote for starting up these actors. And that's how we're going to go ahead. Like if I go down here, we call this after typically we've started the metric aggregator. And I'm going to go ahead and resolve a reference to that actor from the actor registry right here. And then I'm going to inject it into our constructor. And that's what the Spectre.Console actor is going to use to go ahead and get access to that channel reader we had earlier. We have a little shared library right here. This is the only thing in the shared library. It's just our message types. They're all going to be serialized automatically by Akka.NET serialization system. And so this is the protocol we're going to use for communicating between the metrics collector and the agent. The agent is going to also use Akka.Remote. We're going to bind to port 0 because the agents are basically clients. They're not going to accept any incoming connections, so we don't need to worry about giving them a reachable port. It's going to start a metric aggregator actor, and we're going to pass in the server's address, which I'm currently hard coding. I could definitely make that configurable if I wanted to. And then we're also going to start this little CPU collector actor. This is where the middle core numbers actually come from. So this CPU collector actor uses this universe.cpu usage package to gather basically the total amount of CPU time this process has used over its lifespan. So we're able to go ahead and get that down here. We get that value right here. One of the other things that we're going to do is just keep track of our last CPU usage and our last measurement time. And we're going to use basically the delta, sort of the rate of change, to compute what's our current CPU usage since our last report. And we're going to try to convert this into millicores, which is the measure that like Kubernetes and a lot of container orchestrators use for trying to go ahead and measure process utilization. Akka.Streams and Akka.NET are very low CPU utilization platforms, so these values should be pretty low. So we'll see that when we run the demo again. But anyway, we produce these CPU update numbers and we push them to the metric aggregator. Oh, sorry about that. We push them to the metric aggregator that's running on the agent. I should probably give those actors different names. So what this actor is going to do is it's going to go ahead and get the address of the server. We're going to get our own address, so our own network address from Akka.Remote. We are going to stick that as our node address value since that's going to be used in some of our data labels. And we're going to do a little connect loop here where I'm going to say, all right, let's go ahead and try to ping the server. I'm going to start a timer that'll have us retry this connection if it doesn't succeed the first time. If we get the subscribed metrics message back from the server, I'm going to create my source ref right here. This is going to be my way of being able to expose all of my metrics data remotely to the server we're going to connect to. So I'll go ahead and create the source ref down here. Next, I'm going to create a internal source. This is just going to be an actor source. I send this actor data. That's going to result in a message being pushed to the server over the network. So I'm doing that here. I'm going to connect my actor data source to my little source ref right here. And I'm going to transmit that over the network via this push metrics message. And then when I get the receiving metrics message back, I know that we are in a good state here. So I'm going to go ahead and change my behavior to connected. I'm going to empty all the messages in my stash. These are going to be all the CPU events we couldn't process right away. And I'm going to cancel the timer I set up here when I did my initial connect operation. The final thing I'm going to do is I'm going to go ahead and watch that metric source using context.watch. In the event that the server shuts down, all the different little sources that I've set up across all my agents are all going to get terminated. That way, when I detect that the termination has happened down here, I can go ahead and basically retry my whole connect loop all over again. And that's going to basically cause this process to be basically re-entry. It's going to go ahead and retry to connect to the server until it succeeds. Then it'll start streaming data again once that happens. On top of that, we're going to go ahead and just keep gathering CPU updates while we're here. Every time we get a CPU update, we're going to feed it into the stream. and that'll get transmitted over the network. So let's go ahead and run this demo one more time now that we've seen it. Well, looks like we're already working. So I can see here, I've got 3 agent processes. They're all reporting a relatively low number of millicores. That's what you'd expect. I actually found a bug in the millicore formula while I was shooting this video, so now it's accurate. Whereas before it was always growing, which made me confused. That's because I wasn't sampling it properly, so now we are. And yeah, if I go ahead and let's say shut down the server, let me go ahead and do that real quick. I've shut the server down, and you can go ahead and see here, all of my agents have reported that the server was terminated, and they're all trying to reconnect back to it right now. And if I go and I start the server back up again, which I'll do now, you'll go ahead and see that they're all able to go ahead and start pushing data right back into my Spectre.Console table all over again. Yep, there we go. All 3 services are now fully connected back to us. So anyway, if you want to learn more about Akka.Streams, we've got a bunch of great videos on our YouTube channel. Highly recommend you do it. As for Spectre.Console, this library is super easy to get started with. You should just go ahead and fire it up in a brand new application and start playing around with it. All the documentation they put together is excellent. I'll link to that in the description as well. Thank you very much for your time. Please leave a comment.